Welcome to the AI Research Roundup. I'm Alex, and today we're looking at this paper from the Hugging Face trending list, published on the 29th of June, 2025 T, 0 hours 40 minutes and 17 seconds, 0.000Z. This paper, published just 2 days ago, introduces a single 3 billion parameter model that excels at understanding, generating, and editing images, all in one package. The paper is titled Ovis-U1 Technical Report, and the authors show that training these different tasks together actually makes the model better at each one. It details a new unified training approach and introduces architectural innovations to better connect text and visual information. Also, the authors shared their implementation on GitHub. If you head over there, you'll find everything you need to get started, including installation instructions and simple inference scripts. This lets you test out the multimodal understanding, text-to-image generation, and even the image editing capabilities for yourself. On Hugging Face, you can find the 3 billion parameter Ovis-U1 model, with available weights and usage examples for understanding, generation, and even image editing. Alright, so to see what this all-in-one approach looks like in practice, the first figure gives a fantastic overview of the model's capabilities. It's broken down into 3 rows. The top one, Understanding, shows the model describing a scene with fries or reading text from an image. The middle row, Text to Image, shows it generating brand new pictures, like a pug in a cowboy hat. And the bottom image editing row demonstrates it changing existing images, like replacing a yacht with a hot air balloon, really highlighting its versatility as a single, unified system. So how does the model actually pull all this off? This next figure lays out the architecture. At its heart is a shared multimodal large language model, or MLLM, which is a model that can process both text and images together. As you can see, inputs are converted into a special format called embeddings that the multimodal large language model understands. What's really key here are the custom components, like the vision decoder for creating images and a special refiner module that improves how text and visual information work together before an image is made. So making all those components work together requires a really clever training strategy, which is laid out here in 6 distinct stages. You'll notice the little snowflake and flame icons. These show which parts are frozen or held constant and which are actively learning. They start by training just the vision decoder, then progressively activate and fine-tune other parts, like the vision encoder that first processes the image, and a special adapter module that helps connect it to the main model. This careful stage-by-stage process is what allows them to unify these different skills so effectively. Alright, so after all that careful training, let's look at the results. This table compares Ovis-U1 to other leading models, looking at performance across understanding, text-to-image generation, and image editing. It also lists the number of parameters for each model, which are the internal settings the model learns, and a rough indicator of its size and complexity. The first thing you'll notice are the X's, showing many models simply can't do all 3 tasks. Ovis-U1, however, is competitive across the board, proving this unified approach creates a single, versatile, and powerful model. Building on that, this table zooms in on the understanding part of the equation. It shows how Ovis-U1 stacks up against other models on the OpenCompass multimodal academic benchmarks. These are a suite of tests for different skills, like math reasoning, visual question answering, and even detecting hallucinations, which is when a model makes up incorrect information. If you look at the average score on the far right, you'll see Ovis-U1 achieves a 69.6. This score places it ahead of other models in its 3 billion parameter class. So to really prove that their special training method is what makes the difference, the authors ran what's called an ablation study. That's an experiment where you compare a version with a key feature to one without it. This table shows exactly that. The baseline is the model without the full unified training, while the unified training row is the final Ovis-U1 model. As you can see, the average score jumps from about 63.3 to 64.5. It's a clear sign that training all the skills together actually makes the model better at understanding. So wrapping things up, what this paper really shows is the power of a unified approach. The key takeaway isn't just that one model can do 3 different things. It's that training for all of them together, as we saw in that ablation study, actually makes the model better at each one. Ovis-U1, despite its relatively small size, proves that a single, compact system can compete with much larger, specialized models. The plan is to scale it up next and use techniques like reinforcement learning, which is training with feedback to better align with human preferences. That's all for today's AI Research Roundup. Thanks for listening, and I'll see you next time.